once again, thank you for being here at the Zoom 2023. Very much looking forward to your presentation because I missed it at ROS because I was too busy at the booth. And they told me it was quite incredible. So, I didn't look any recording because I wanted to listen it from you live. So you work at NXP, and suspense. I don't want to unveil anything because I think your use case is super cool. The floor is yours. Let me share the screen, your screen, and you are live. The floor is yours. Good luck.
Okay. Well, hello. Welcome all to my presentation about Zenoh on PX4 for multicast distributed networking between PX4 and ROS 2 nodes. I think it's lots of jargon, but mostly we've been using Zenoh Pico specifically for PX4 autopilots to communicate with also bigger system ROS 2 based systems. So a short introduction about myself. So I'm Peter van Perk. I work at NXP Semiconductors and I work for CTO System Innovations. And inside there we have a mobile robotics team where we look on how to think about applications of NXP products inside this mobile robotics space. We make reference designs, we make development platforms, we think about networking, and NXP is quite big in vehicle networking. You think about the classical LIN, flex, CAN, but also Ethernet, battery systems. And on top of that, we also organize competitions. So we have Hover Games and NXP Cup, where you have these reference platforms for students to play around with. And actually for us, it's a very nice base platform to try new technology. So how does that look like? So this is a very brief system block diagram of mobile robotics. We have most of our legacy in CAN. So typically we're thinking about a CAN bus where you have different kind of sensors, RTK, GPS, but you see this, I would say, new revolution or convergence between cloud networking or normal PC networking, where typical Ethernet-based solutions also come in there, which also we have solutions for. We're showcasing. So we have flight controllers, vehicle management units. So we think about real-time systems. You have Linux systems. We have Ethernet-based systems, and then we have sensors and actuators. And this is kind of rough picture of our portfolio. And based on that, we make demonstrators. So this is just a basic presentation I used for the PX4 Autopilot Summit. So that's a autopilot to control drones. So some information is just quite basic. If people are familiar with Zenoh, they probably know it. But roughly what we see is that this publish-subscribe pattern, it helps you a lot with software development because you can make separate nodes. If you look at the picture I had before, you have different kind of nodes, sensors, actuators, but you want to simplify that. So you want to think about a topic, you have kind of data topics, you have publishers, you have subscribers using that data. So inside of PX4, even this concept is also used, and they use a inter-process communication. They made their own system called UARP, but this is just limited on the chip itself. So let's say you have a sensor node processing IMU data, and you have an actuator for the outputs, but that just stays on the chip. But you see that these systems become more advanced and also more autonomous, and you want to even bridge those. So for ROS2, you see that DDS is used for that. That works on chip, but also off chip. But what we see is especially bridging DDS with small microcontrollers. DDS tends to be quite big. So roughly an overview of the middleware I've encountered working on robotics. So kind of like the typical ROS1 TCP ROS. So we had a publish subscribe. We needed a ROS1 master, so it's kind of brokered connection. And with DDS, the nice part is that this became decoupled, right? So we can do a peer-to-peer communication, and we don't have the dependency of this ROS master. It's UDP. Also, DDS brings some interesting technology regarding redundancy, liveness. So it's more in line with proper networking. But if we want to integrate it on smaller microcontrollers, we had some struggles. And I think since May this year, I saw that Zenoh Pico was implementing also the peer-to-peer communication. That's kind of where we were like, okay, let's try to implement this on the microcontroller and bridge these two, where we can also have a small microcontroller participating in the DDS domain. And what I'm also very excited about is even that Zenoh now becomes an alternative middleware for ROS. So even we don't have to necessarily bridge, but we still have the flexibility for that. So very rough introduction on PX4 middleware. So PX4 typically is a FMU, which is a flight management unit. So that's a microcontroller that takes care of all the sensors, actuation, and tries to stabilize the drone. It runs the NUDX operating system, which is a small RTOS. And then internally, we have this MIORP to have all these sensors, attitude control, RC input. And what they do right now is they use a bridge mechanism, which is based on XRC DDS, and then they can use an agent to communicate with a ROS2 based system. Fortunately, what we had is we were also looking at functional safety and fallback mechanisms. If we want to add a second flight controller or other small embedded based systems, we always have to go to this agent. So that's what we really wanted to avoid. And we also have Ethernet switches and multicast solutions, and we'll go further into that. And we want to utilize that solution where XRDDS was kind of lacking for the things we want to use. But this is roughly how an autonomous drone system with PX4 could look like. Roughly introduction to Zenoh. So the nice part, what we liked about it, it scales from big systems to small systems, and also the fact that it supports different wire formats. So we still have systems where you might have to use serial, USB serial, Bluetooth. So even the things where we're looking at, we see that, hey, it's very extensible. And from the end user, we like the concept, okay, well, you can do this publish subscribe through this API on a high level, and then everything beneath it should take care of it. Well, should take care of that. That's the goal you have in mind, and I think Zenoh does a very good job, also with the router, and has worked it out nicely. Um, so yeah, we come to the router part. So typically we are interested into P2P communication, but even the brokered and the meshing network is still very interesting for us as well. If we think about different setups, so if we think about a combined system, we could have multiple vehicles through routers. We could have a ground control station. That's the terminology they use for drones. So you're flying your system, you're on the ground, you have a 4G uplink, or you have other links. And the nice part, you can use Zenoh to route the data back to you to get real-time status of your vehicle. And if 4G, you can also bring that into cloud. So what you see that even if you think about the nice topology image of Zenoh, it really pairs nicely to multiple robotic systems where you can have interconnection and have all these fleet control, and we can use one protocol for that. So that's really a concept we want to use. But mostly we just started with Zenoh to ROS2 bridging. So we have ported Zenoh to the PX4 autopilot. We have a router running on a Linux system, and then we use the DDS bridge to bridge it with ROS2 nodes. So we had some challenge to port this. So still, if we want to communicate with ROS2, we also have to implement the ROS2 serialization. And that's specifically to DDS. It's called CDR. That's the serialization library. But the nice part is there is this Cyclone DDS implementation where you can use these serialize also as a separate library. And that seems to be small and portable enough to run on small microcontrollers. So what we did is we converted the internal communication system that PX4 uses to this IDL format, so we can generate serialized data for Cyclone DDS. And then we can serialize it the same way how ROS wants to have it serialized. And then the nice part is actually all the internal topics we now have on PX4, we can publish those to a Zenoh network, and we can decode it on ROS2, but also we can decode it on other systems. So how does that look like? Well, so this is the kind of architecture we are interested in. to think about redundancy. So we could have a flight controller, but even a second flight controller, but then you have to synchronize those states. And if you think about autonomy, you want to also add a companion system. So what we typically would have if you have DDS6RC as an agent or some kind of auto protocol MQTT, you always have to send from system 1 to system 2 to system 3. But the nice part about Zenoh is that it's implementing multicasting. So the switch can already duplicate the packet for you. Especially on small systems, this is important because we just want to send a single packet, and it's kind of like fire forget for that. So we don't need a broker. The switch takes care of it, and we don't have much overhead even if the network grows. And also the nice part is where you have these small real-time systems, we can utilize all the features that ROS has. So we can also use ROS specs for logging. That's one nice thing we have, so we can figure out how things are happening if we do want to test takeover scenarios. So yeah, it becomes very extensible. So how does it look like? So this is a very simple example. So on PX4, there's this internal topic, which is a remote controller. So there's a 2.4 gigahertz remote controller. We publish this on Zenoh, and then thanks to the Zenoh bridging, we can get um, the data over to ROS2. So yeah, you should see now, yeah, you get all the data, you see that the values are changing. We can look it in the ROS2 back, we can modify, we can also monitor this and also duplicate that. So this is the mostly the ROS2 bridging, which is actually kind of bonus because our primary focus was actually working on a redundant setup. So what we had is we have a remote controller. As an example, we sent this to a switch, and the switch does this multicasting. It gets sent to both flight controllers. They both have their own internal control loop, and then we can send out two independent actuation commands to the speed controller, and then either FMU can fill, the ESC can still operate. Also, what we utilize here is 100 base T1, which is two-wire Ethernet, automotive Ethernet. Oh, so this is the platform we use. So this is a small microcontroller that implements this two-wire Ethernet. It's maybe you can see my cursor. Maybe I should turn it into a pointer. But this is just this very tiny two-wire unshielded Ethernet, so it does 100 Mbit. So you didn't even need huge connectors. It's even smaller compared to Canvas. And we get all the automotive functionality, which is also interesting still to look at the Zenoh is the time-sensitive networking. This hardware is enabled for it, but we still have to experiment it. And then we have got a flight controller running on this platform. And then we have a very small switch. So this is 7.5 times 5 centimeters. So this is a 8-port switch that does this two-wire Ethernet, and also for the sake of debugging, we can easily just put an RJ45. If you see compared to the small force RJ45 looks huge. And this is like an in-vehicle network for a small robot or for automotive. Automotive uses a lot now. But then what you see is that you're migrating from CAN bus to Ethernet, and okay, what kind of protocols can simplify that for you? So this is a demonstration of that. So in the center we have the switch. We have one system that takes the remote control input. We send it to the switch. The switch acts as a multicast system. And then we have two systems controlling the speed controller. And then we have a nice visualization on how the motor should turn. Okay, yes, now the picture is working. So we are sending speed commands. We do the steering actuation. And what we now show is that either this canvas can fill, so we have written in the canvas, so we can just take out the canvas, but the system still operates because it takes in the same actuation command from the user. So this is a nice example where we can think about redundant networking setups. So for now in PX4, we have implemented Zenoh Pico. It's still based on the old 0 7.0 functionality. I'm trying to work on the newest Zenoh release, Dragonite. Well, also exciting about the Zenoh alternative RMW. So hopefully we can even do some experiments without using the router DDS bridge, just having a basic implementation. And yeah, crowd control, cloud communication through Zenoh. I think this is a very unexplored area, and I think there's some opportunity there. And also, I'm curious if people are interested in here as well. Should I just put it? There's kind of like this unification of Ethernet campus through Zenoh. So can we also maybe, like Zenoh is quite versatile. You can use it on serial TCP UDP. Could you also use it on Canvas and even use Canvas networking for very small sensors? Like you have these voltage sensors or small buttons like a safety button. Can you utilize Canvas for that and then still bring that into Zenoh and into the ROS or into other system where you can think feel safe mechanism, but then from the end user they can just use one same framework. So these are interesting things to explore. For now, we're mostly focusing, enabling it on our small microcontrollers. All we do is open source, so we try to contribute to PX4. I did some contributions to Zenoh Pico, and for us, it's more to showcase our reference platforms. Yeah, so thank you for listening to presentations. If there are questions, feel free to contact me. My email is also here.
So thank you very much for your presentation, Peter. As always, the question will be on social media, right? Because we are streaming live of multiple social media. So keep an eye, and otherwise,
Okay.
there are your contacts. So thanks again for your great presentation. And next is Sarah. Oh, here we are. Okay, here you are, Sarah. So let me bring you online. Hello, Sarah. How are you?
Hi, I'm good.
Okay, perfect. So as you share your screen, Sarah, because I'm coordinating everything from here, so I decide what comes on the screen. Peter, thank you again, and
Yes.
see you soon, and keep us posted with your developments. And
Yes.
concerning Canvas, yes, I mean, this is something we would really look forward having. I was discussing as far as what was it last Friday with one of our engineer. He might end up doing a plugin for CAN that would
Okay.
already allow us, right, to yeah. So hopefully we should have that. And I don't know, Patrick, if you're hearing me. So lots, you already know that lots of people are looking for it. We'll keep you posted. Okay.
Okay. Great.
This is what we would like to have at least I would like to see in first instance, and then I mean we could have a profile of Zenoh running on Canvas, but that requires some little bit more work, especially for very small, the lower end version of CAN.
Yeah.
So keep up with the great work. Thank you again, and stay tuned.
Yes.
Bye, Pete.
Well, thanks. Bye.